Hi everyone, today a video on alkenes and specifically on the polymerization of alkenes. So alkenes are polymerized through a technique called addition polymerization. Now in this type of polymerization we have something called a monomer, which is the smallest repeating unit, in this case the unsaturated unit of the alkene, and we have lots and lots of these alkene molecules, in this case ethene, being added together. And essentially what happens is you can imagine the double bond kind of gets cracked open, split open, and it ends up forming this long chain molecule, which is the polymer. Now, as you'll see, the polymer essentially is an alkane. It's a saturated molecule, whereas the monomer was our alkene, our unsaturated alkene. So monomers are always unsaturated. They're the alkenes. Polymers are always saturated, and they are essentially alkanes. Now, the slightly annoying thing is that the way they're named. If in this case, the monomer was ethene, the polymer is called polyethene. Even though the polymer is a saturated molecule, it's named after the alkene. So it's always named as polyalkene or polymonomer. But it's really important to know that addition polymers are alkanes. They are long chain alkanes. They are made from alkenes and they are named after alkenes. So make sure that's clear. We can also represent them sort of more neatly as the equation shows at the bottom, where we have n amount of our monomers forming this, what we call the repeat unit here, shown between the brackets, with the single bonds from the carbon extending out past those brackets to show that it continues on and on, with the n at the bottom to show that it was how many monomers it was made from. So the repeating unit, is the smallest group of atoms that produce the polymer when it's repeated over and over. And so essentially the smallest repeating unit is the monomer, and it must be at least 2 carbons long. When we have this top example where we've made the polyethene, the monomer was ethene, we could say technically that the repeating unit is just a CH2 group. However, typically the repeating units are based off the monomer, hence they are 2 carbons long. So the repeat unit there is that CH2 group shown within the red brackets. Another example would be the one at the bottom, and so we can see here that the repeating unit is this CH2 group shown in the red brackets. Essentially, to go back from the long chain alkane, this polymer, back to the repeating sort of monomer that we started with, is to kind of do the reverse, is to imagine the two ends of the single bonds on those carbons kind of folding back in to make a double bond. And so we essentially just put a double bond in between those 2 carbon atoms and we have our monomer back. So in this case, essentially we have some sort of chloro derivative of ethene. So addition polymers are long chain hydrocarbons. Even though they're named as polyethene, for example, remember that they are long chain hydrocarbons. They are saturated and they are non-polar. The intermolecular forces are van der Waals forces. They're typically made of just carbons and hydrogens mostly, and so there's no permanent dipole forces, there's no hydrogen bonding, it's just van der Waals forces. So typically as these polymers get bigger, their melting and boiling points increase because larger molecules have more electrons and stronger van der Waals forces. Since the CC and the CH bonds are non-polar, they're not soluble in water and they're generally pretty unreactive and chemically inert. And we'll see in a few slides' time that that's a bit of a problem. Now the conditions that we use, i.e. the pressure, the temperature, will affect the properties of the polymer. Also, branched polymers will be more flexible and can be stretched more and will have lower melting and boiling points than strict chain polymers or less branched polymers. And so the reason here they're more flexible and the fact that they have lower melting and boiling points is purely because they can't pack together as neatly, as close together, and so the van der Waals forces are less able to interact. Low density polyethene is made at high pressure and high temperature via a free radical mechanism. It uses radicals. And this actually produces a very, very highly branched polymer because radical reactions tend to be very, very random in nature. And so low density polyethene, LDPE, is quite flexible. It's very branched, so it's flexible, it stretches quite well. It has a low density because it can't pack together. You can imagine these chains sort of sticking out everywhere, not allowing it to pack together very neatly. High density polyethylene is made at much lower pressure and temperatures and uses something called a Ziegler-Natta catalyst. It's a much less branched polymer because the reactivity is much more neatly controlled. And so the chains pack together much better, and so the density and the melting temperature is higher because the van der Waals forces are able to interact more strongly. So one of the monomers that we saw earlier was this one shown in the bottom right, and the polymer that this makes is called polychloroethene. It's commonly known as PVC, it stands for polyvinyl chloride. That's sort of the name for it. It's very tough, it's cheap, and it's long lasting. And it has many different applications. It's used in vinyl records, window frames, food packaging, construction, water pipes, for example. So it has lots and lots of properties, lots of different applications, and the properties that you can imagine have to be very different in a vinyl record to in a window frame. And so the properties can be modified by using something called a plasticizer. So in this case, we now actually have a polar bond. We have a carbon-chlorine polar bond. So we have some additional intermolecular forces. We have dipole-dipole forces being able to act between the chains of the molecules. And what a plasticizer does essentially is it gets in between these polymer chains and it reduces the interactions. And by reducing the interactions, it makes the plastic more flexible because the chains now aren't able to interact as strongly, and so they can be stretched and they can be they can slide over each other a bit more. So our monomer here is chloroethene, and the monomer is the smallest repeating unit. It's unsaturated alkene. It makes the polymer, which is polychloroethene, which is saturated, a long chain chloroalkane. Now, obviously, the plastics are very useful in everyday life. We have so many different products that are made out of them, and they improve our lives massively. But as we've said, addition polymers are long chain alkanes. They are very unreactive because they contain typically very little polar bonds, and they're chemically inert. The molecules are saturated for the majority of them. The only intermolecular force is the van der Waals forces. And so what this means is that we can't break down these addition polymers through biological agents such as enzymes or water. They're not biodegradable. And so what that means is that they don't break down naturally, and so they clog up landfill sites. And so what we need to do is either to reduce the amount of plastic we use or to start recycling it. And even that throws up some problems in that in terms of recycling it, typically what happens is you sort the plastics into different types. These then get taken away, melted down back to their constituent kind of monomers, and then reformed into a new plastic type. And this is great to an extent, but repeatedly melting these plastics down can also actually degrade some of the properties of the polymer. So if you wanted a really flexible polymer for a certain type of application, the repeated kind of melting down of this and reforming could end up making it more brittle and therefore not useful for its purpose. So time to have a go at some questions. So have a go if you want to, and pause the video, and the answers will be on the next slide. And so the questions here is polypentene an alkane or an alkene? And to name the following compound, determine its repeating unit, and to name the monomer. So the first question is that the polymers are, of course, alkanes. They're long chain alkanes, even though they're named after the alkene. And it's the monomer that is the unsaturated alkene. Then we have this molecule here, and the easiest way to go about it is to actually name the monomer first. So we need to look for the repeating unit. So all we simply do is we look for where a set of atoms repeats. So if we go from left to right, we have a carbon with a chlorine and a hydrogen, a carbon with a hydrogen and a CH3. Then we have a carbon with a chlorine and a hydrogen. We've repeated. So we look for where essentially the next repeat is, and we cut off just before there. So we have our CClH group, our CH3 group. That's our repeating unit, because the next one along is the carbon with the chlorine on again. So we think about drawing our monomer out. Imagine just putting a double bond in between those two carbons. We then need to name the monomer. Our longest chain is 3 carbons long. We have a chloro group on carbon number 1, and it's an alkene, so we're going to name it with the suffix -ene. So it's 1-chloroprop-1-ene. We also have the ability here to look at EZ isomerization. Now remember that we need to look for the atomic weights, the atomic numbers of the groups that are attached. And here we have two heavy groups. We have a chlorine and we have a CH3. And in this case, the chlorine and the CH3 are in different signs. One is above and one is below the alkene. And so this is E1-chloropropionine. And so the name of the molecule is poly E1-chloropropionine. So thank you for watching this video. I hope you found it useful. There are lots more videos like this on my YouTube channel. If you have found it useful, please consider leaving a review on the tuition website. I offer online tuition for chemistry, so please check my tuition pages for prices and how to contact me. And if you need any more help with your chemistry, you can always email me. I'm always happy to help.